Welcome to Astronomy Daily, where we explore the latest developments in space exploration and astronomical discoveries. Today's episode covers a range of exciting topics from lunar navigation systems to space station expansions, solar storms, and innovative rocket technologies. I'm your host, Anna, bringing you the most fascinating news from beyond our atmosphere. So let's get started on today's news. Imagine driving around on the moon and pulling up your navigation app. That future is closer than you might think. Spanish technology company GMV has unveiled a groundbreaking navigation system called Lupin, essentially creating GPS for the lunar surface. This revolutionary technology aims to make lunar exploration as intuitive as using Google Maps or Waze here on Earth. It's addressing one of the most significant challenges faced by lunar missions today. Currently, navigating the moon is incredibly difficult. Spacecraft on the lunar surface must rely on complex calculations and data relayed from Earth, a process that's neither quick nor precise. Communication depends on direct visibility with Earth or relay satellites, creating shadow zones and frustrating delays that hinder immediate decision-making. Lupin would change all that by using signals from moon-orbiting satellites, allowing rovers and astronauts to pinpoint their location in real time. The system would be particularly valuable in previously inaccessible or difficult to navigate areas like the dark spots of the lunar South Pole and the far side of the moon. The project is part of a program by the European Space Agency to test new positioning techniques as interest in lunar exploration accelerates. GMV has already conducted field trials with a prototype in Spain's Canary Islands, specifically Fuerteventura, where the landscape bears some resemblance to the lunar surface. As Stephen Kay, the project's director, explained, with this software, we bring Europe closer to establishing a presence of humans on the moon, and potentially this would be a stepping stone towards Mars exploration. Next today, China is preparing to expand its Tiangong Space Station with new modules using the country's most powerful rocket, the Long March 5B. According to officials from China Aerospace Science and Technology Corporation, this expansion is designed to meet growing experimental demands, which are placing higher requirements on the station's available space and energy supply. While no official timeline has been released for these missions, reports indicate that the first edition is likely to be a multifunctional expansion module. This module would feature 6 docking ports and would connect to Tiangong's core Tianhe module, allowing for further modules to be integrated into the station in the future. This expansion would significantly enhance opportunities for scientific research, payload hosting, and international cooperation. Earlier this year, China announced plans to train astronauts from Pakistan to fly to Tiangong in what would be the first international astronauts to visit the Chinese station. Officials have also indicated they're in discussions with other countries about sending their astronauts to Tiangong. China is simultaneously developing a new generation crew spacecraft with 2 variants, one for low Earth orbit that could carry up to 7 astronauts to Tiangong, and another named Mengzhou for crewed lunar missions planned before 2030. This commitment to expanding Tiangong signals China's determination to maintain a permanent human presence in low Earth orbit, independent of the International Space Station. While NASA has proposed reducing funding for ISS operations, China is clearly investing in its own orbital outpost for the long term. My, how time flies. It's been exactly 1 year since the historic May 2024 solar storm, also known as the Ganon storm or Mother's Day solar storm, which NOAA has ranked as one of the most memorable solar events in history and potentially the most powerful documented this century. What made this event so extraordinary was its sheer magnitude. At least 8 coronal mass ejections targeting Earth from a single massive sunspot group that measured an astonishing 17 times wider than Earth's diameter. Many of us remember those breathtaking images of aurora displays visible at exceptionally low latitudes, with people witnessing the northern lights in regions that had never experienced such phenomena before. Social media was flooded with spectacular photos as the night skies lit up with vibrant greens and reds across the globe. But beyond the beautiful light show, the storm revealed critical vulnerabilities in our technological infrastructure. The agriculture industry was particularly affected, as precision farming equipment that relies heavily on GPS systems experienced significant disruptions. Tractors using satellite guidance systems for planting suddenly lost positioning data, bringing operations to a halt at a crucial time in the growing season. Scientists have widely credited NOAA's Space Weather Prediction Center for providing crucial early warnings ahead of the storm. These timely alerts allowed power grid operators to implement protective measures that prevented what could have been crippling electrical failures across wide regions. This success story demonstrates how proper preparation and early detection systems can mitigate the impacts of even extreme space weather events. Next, an innovation that many will be watching closely. Rocket Lab has made a significant move in the evolving field of point-to-point cargo transportation with their recent announcement of a new contract with the U.S. Air Force Research Laboratory. The aerospace company plans to demonstrate the reusability of their forthcoming Neutron rocket through a return-to-Earth mission scheduled for no earlier than 2026. This mission represents an important milestone in the AFRL's rocket experimentation for Global Agile Logistics Program, known as REGAL. The program focuses specifically on the Department of Defense's ambitious goal of establishing rapid point-to-point cargo transportation using orbital-class rockets, essentially creating a system where critical supplies could be delivered anywhere on Earth within hours rather than days. During Rocket Lab's first quarter earnings call, CEO Peter Beck emphasized that Neutron was designed from the ground up with reusability and launch frequency in mind. We know re-entry and rocket reusability is a critical advancement in space tech that the DoD is highly supportive of, Beck noted, highlighting how these features make Neutron particularly well-suited for the military's logistics requirements. The mission is being described as multi-manifest, though specific details about the payloads remain limited. What we do know is that the AFRL's experiment will launch aboard Neutron and then re-enter Earth's atmosphere, demonstrating capabilities that will be crucial for future REGAL missions. Meanwhile, development of the Neutron rocket continues to progress steadily. The company reports that second stage qualification is now complete, while stage 1 qualification testing remains underway. The second stage is currently in final assembly and will be shipped to the Mid-Atlantic Regional Spaceport at NASA's Wallops Flight Facility in Virginia within the next few months for integration with its engine. The rocket is on track for its debut launch in the latter half of 2025. Finally today, some interesting history and trivia for you. When we talk about extended space missions, few stories captured public attention like that of Butch Wilmore and Suni Williams. What began as a planned 8-day mission to the International Space Station in June 2024 stretched into a 9-month odyssey when issues with Boeing's Starliner capsule prevented their scheduled return. The pair finally splashed down near Florida in March 2025, having missed birthdays, holidays, and countless family events. While media outlets frequently described Wilmore and Williams as stranded in space, this characterization isn't entirely accurate. As veteran astronaut Ken Bowersox later pointed out, every crew member who flies to the ISS always has a vehicle available for emergency return. It's a fundamental safety requirement of spaceflight operations. Interestingly, extended missions have a long and storied history in space exploration. Mark Vande Hey, who launched to the ISS in April 2021, saw his planned 6-month mission double in length when his return seat was given to accommodate a Russian film crew. The director and actress needed Vande Hey's spot on the Soyuz capsule to return home after filming the first fictional movie in space. This unexpected extension resulted in Vande Hey spending 355 days in orbit. His record wouldn't stand for long. Frank Rubio surpassed it when his 6-month mission transformed into a 371-day journey after his Soyuz spacecraft suffered a coolant leak in December 2022. The damaged vessel had to return empty, forcing Rubio to wait for the next available spacecraft. These recent examples follow a pattern established decades ago. The Expedition 6 crew of Ken Bowersox and Don Pettit faced their own extended stay following the Columbia disaster in 2003. With the shuttle fleet grounded, they had to adapt to returning on a Russian Soyuz instead, enduring a harrowing ballistic re-entry that subjected them to 2 times the normal G-forces. Perhaps most remarkable was the case of Soviet cosmonaut Sergei Krikalev, who launched to the Mir space station in May 1991 as a citizen of the Soviet Union, only to return in March 1992 to a world where his country no longer existed. Political and economic upheaval on Earth had extended his mission to 311 days, earning him the nickname the last citizen of the USSR. Even earlier, cosmonauts Vladimir Lyakov and Valery Ryumin faced an extended mission aboard Salyut 6 in 1979 when engine problems with their replacement Soyuz capsule forced mission planners to develop alternative return scenarios. These extended missions reveal not just the technical challenges of spaceflight, but the remarkable psychological resilience of those who venture beyond Earth's atmosphere, ready to adapt when circumstances demand flexibility far from home. The stories we've covered today reflect the accelerating pace of space exploration and innovation. We're standing at a fascinating crossroads in humanity's relationship with space, where once theoretical capabilities are becoming practical realities. Consider the Lupin lunar navigation system developed by GMV. This technology could transform lunar exploration from a complex technical challenge into something as intuitive as using a smartphone app. As we establish more permanent presences on the moon, such navigation tools will be essential infrastructure for everything from scientific research to potential resource utilization and even tourism. Then there's China's expansion of the Tiangong Space Station, which represents another significant development. As the ISS approaches the latter stages of its operational life, we're witnessing the emergence of new orbital platforms that will ensure humanity maintains its foothold in low Earth orbit. These expanded facilities will serve as crucial testbeds for technologies needed for deeper space exploration. The Ganon solar storm's anniversary reminds us of our vulnerability to space weather. The impacts on farming equipment demonstrate how deeply space-based technologies like GPS have become integrated into our daily lives. Building resilience against such events isn't just about protecting astronauts, but about safeguarding our entire technological civilization. Rocket Lab's point-to-point transportation capability could revolutionize logistics on Earth. Imagine critical supplies being delivered anywhere on the planet within an hour. The implications for disaster response, military operations, and global commerce are profound. Finally, the lessons from extended astronaut missions provide invaluable insights as we prepare for Mars journeys that will require crews to spend years away from Earth. These inadvertent experiments in prolonged spaceflight have given us data on everything from psychological adaptation to long-term physiological effects that will inform our next giant leaps into the cosmos. Together, these developments paint a picture of a species increasingly comfortable with operating beyond Earth, developing the technologies and experiences that will ultimately transform us into a multi-planetary civilization. That's all for today's episode of Astronomy Daily. I'm Anna, and I've been thrilled to share these fascinating space developments with you. From lunar GPS systems to expanding space stations, historic solar storms, revolutionary rocket technology, and the remarkable resilience of astronauts on extended missions, our cosmic neighborhood continues to inspire and challenge us in equal measure. If you enjoyed the show, please visit our website at astronomydaily.io, where you can listen to all our back episodes. We have a rich archive of space news and deep dives into astronomical phenomena that I think you'll find fascinating. Subscribe to the podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. Also, follow us on social media by searching for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, Tumblr, and TikTok for exclusive content and updates. Thank you for joining me on this cosmic journey. The universe is vast and full of wonders, and I'm honored to be your guide through its latest discoveries and developments. I'll see you again soon for more exciting news from the final frontier. In the meantime, keep looking up. You never know what you might see out there.